particle motion is one of the most important concepts we're going to study because it is dispersed throughout a very large part of your AP exam, and it's one of the major uses for AP Calculus. Position of a function is given typically by the function s of t, especially in physics. S of t is spatia, means the space between things, where t is time and s is the height or position of an object. Velocity is represented by v of t, so notice that your input variable is time and your output or your y variable is v, but that is found by finding s prime of t. It's the change in position over the change in time. Speed is the absolute value of velocity, so a negative velocity would tell us our speed in a negative downward or reverse direction. A positive velocity would tell us our speed in a forward, upward, or positive direction motion. Acceleration of an object is the rate of change of velocity. So acceleration is the slope of velocity. So it's speeding up or slowing down, so it's a change in velocity over time, which means it's the second derivative of position with respect to time. So remember, velocity, for example, could be in feet per second if our position was measured in feet and time in seconds. A speed would also be in feet per second, but it would have to be the absolute value because speed doesn't care what direction we're going, only how fast. So for example, if I were driving through a parking lot and the posted speed limit was 5 miles per hour, and I thought it would be fun to put myself into reverse and go 40 miles an hour backwards, I'm still going to get a ticket, even though negative 40 is less than 15 or 5. The absolute value is my speed, so I'm really still going 40 miles an hour just in the reverse direction. Okay, acceleration again is a change in velocity, so if you're pressing that accelerator pedal to speed up or pressing the brakes to slow down. Displacement is very often confused for position. Displacement is the difference between our position on time A to B. So if my time interval is between A and B, then my displacement is the difference in my position. Displacement can be negative because I can be further to the left or below my initial position. So this is relative to the initial position. So if you are more negative in direction, if you think of east as positive on the x-axis and west as negative on the x-axis, then you could be further west and end up with a negative displacement. Similarly, your position is relative to a starting point typically, so your position has to be somewhere in space that could be either positive or negative. So let's look at an example. The position of an object at time t seconds is given by s of t equals t cubed minus 6t squared plus 9t measured in meters. So notice they're telling me that s, position, is measured in meters, and time is measured in seconds. Also, they're not telling me the distance that I've traveled when they do this. They're only telling me my position in space. So my position at time 1, s of 1, is 1 cubed minus 6 times 1 squared plus 9 times 1. So 1 minus 6 times 1, which is 6, plus 9 times 1, which is 9. So 1 minus 6 plus 9 is 4, and s is measured in meters. If a problem provides units, you must also provide units with all of your answers. However, if a problem does not provide units, you absolutely should not include them, and you should never make up your own units. Okay, the next question says, what is the velocity of the object at 2 seconds? The velocity at 2 seconds is the instantaneous rate of change. So we find the velocity at a particular time by taking the derivative of position at any time. So that's going to be 3t squared minus 12t plus 9 for this particular function using the power rule. So the velocity specifically at time 2 is going to be the derivative of s at time 2, which is 2 squared minus 12 times 2 plus 9. 3 times 4 is 12. 12 times 2 is 24. And we still have the plus 9. So overall, we end up with a negative 3. Remember, this is velocity. Velocity is measured in things like miles per hour, or in this case, meters per second. Now, the speed at time 2, remember, is the absolute value of the velocity at time 2. So it's the absolute value of that negative 3. So just 3 meters per second. Okay, so remember, acceleration is a change in velocity. So it's the derivative of velocity at any time. Or the second derivative of position, since we have to take 2 derivatives to get there from starting at position. So we already have the first derivative, which is velocity. We take the derivative again using the power rule, and we have 6t minus 12. Now the acceleration at time 5 is v prime at 5, or s double prime at 5. So that makes it 6 times the quantity 5 minus 12. That's 30 minus 12, or 18. And acceleration is measured in meters per second because it's really the slope of velocity. So if acceleration is a change in velocity over time, then the velocity units are on top. But if we simplify that out, it's 18 meters per second squared. Now remember, the displacement is not the same thing as the distance. It's a change in position. So it's the position at time 5 minus the position at time 2. It always has to be the second minus the first. So if we go back to our original function, which is our s of t, s of 5 is equal to 5 cubed minus 6 times 5 squared plus 9 times 5. That means that the position at time 5 is 125. 6 times 25 is 150, and 9 times 5 is 45. So overall, we end up with a positive 20. Since this is position, it would be measured in meters. Okay, so similarly, we're going to find the position at time 2 is 2 cubed minus 6 times 2 squared plus 9 times 2. 2 cubed is 8, 6 times 4 is 12, and 9 times 2 is 18. So we end up with 14 meters. So my initial position is 14 meters. My final position is 20 meters. So the difference, 20 minus 14, is 6 meters. It does matter what order. Because I went from 14 meters to 20 meters, I have to represent that as a positive 6. I need to know that that's a gain of 6 meters. For the next problem, the object moves along a path so that its position x of t is defined by this function. That typically implies that we're moving along a horizontal line, backwards and forwards. The velocity when t equals 1 and t equals 6 means I want the velocity function, which is the derivative of position, which is 6t squared minus 24, using the power rule, so that I could find the velocity at time 1, which would be 6 minus 24, so negative 18. Remember, it's centimeters and seconds. Remember that velocity is really a change in position over a change in time. So that's centimeters per second. The negative represents the fact that if we were on the x number line, we would be moving to the left at a speed of 18 centimeters per second. Now the velocity at time 6 is 6 times 6 squared minus 24. That's basically 6 cubed, which is 216. Now 216 minus 24 is 192. We are still doing velocity, which is still a change in position over a change in time, so it's still centimeters per second. That means at some point in time, between time 1 and time 6, we stopped moving to the left and started moving to the right, and we're actually going quite a bit faster now. Okay, now this next question is typically answered incorrectly by students because they substitute in time equals 0 when they don't read the problem appropriately. When is the velocity 0 means we don't know what t is equal to. We want the velocity to equal 0. So we're going to take our velocity function and set that equal to 0. Solving 6t squared would equal 24. Dividing by 6, t squared would equal 4. And technically, the algebra answer is t equals plus and minus the square root of 4. But because we have a restriction given to us, and only because of that restriction, we can only choose time equal to 2 because we weren't allowed to have past tenses in there. Okay, now determining the acceleration at time 1. Remember, acceleration is a change in velocity over time, which is our v prime. So we're going to go back to our velocity function and use the power rule and get just 12t, because remember the derivative of a constant is 0. So the acceleration at time 1 is 12 times 1, or just 12. Remember, acceleration is the slope of velocity, so it's velocity over time, which means it's centimeters per second, which was velocity, divided by time, or simplified out, that's centimeters per second squared. Now, something to note on here is that just because you have a positive acceleration does not mean that you're speeding up. At time 1, we had a negative velocity. At time 1, we have a positive acceleration. So at time 1, the object is slowing down at a rate of 12 centimeters per second, or centimeters per second squared, because velocity and acceleration have opposite signs. That's an extremely important concept because these are vectors that are competing against each other. So something to note is that if you have a positive velocity or a negative velocity, that tells me direction. If I have a positive velocity with a positive acceleration, that means I'm speeding up in the forward direction. If I had a positive velocity with a negative acceleration, that would mean with a positive velocity and a negative acceleration, they're competing, so I would still be moving forward, but the combination of having the opposite signs would mean that I'm slowing down in the forward direction. If I have a negative velocity and a positive acceleration, a negative velocity and a positive acceleration, that would mean I'm going backwards, but the acceleration is trying to stop me. So I'm going backwards, and the combination says I'm slowing down. Whereas if I had a positive acceleration with a positive velocity, we're speeding up. What if I change it to a negative acceleration and a negative velocity? That means I'm going backwards because of the velocity telling me direction, and it's only in combination that I see we have the same sign, so I'm going faster. So I would be speeding up in the backward direction. Okay, so on my calculator, if I have a position that's 2 minus 2 sine x, and then I have the derivative of position, the derivative of position is velocity. I could then take the derivative of the derivative. So basically the second derivative at every x value. So I'm not going to graph these ever, but what I have now on my list, I want to pull that over, is I basically have my position function. I have the derivative of y1, so the derivative of position is velocity. One. Finally, the derivative of the y2 function is the derivative of velocity, is acceleration. So now I can use my calculator to calculate any of those values. So at time pi over 4, the y1 function, which was position, I can put this in as a fraction. Would tell me the position at time pi over 4. Similarly, I'm going to go up and highlight that to grab it. I'm going to go back to the front by pressing second left. And then I'm going to change this to y2. So y2 of pi over 4 is the velocity of pi over 4. So my position at pi over 4 is about 0.586. my velocity at pi over 4 is approximately negative 1.414, which you might recognize as about negative square root of 2. And finally, I can highlight it again, press enter, second left to go to the beginning, and change this to the y3 function, which is the acceleration at pi over 4. So my acceleration at pi over 4 is approximately 1.414, or a positive square root of 2. What that tells me is that I'm going in the backwards, or since this is an x number line, coordinate line for x, backwards really means to the left for x. And since these two values, one is positive and one is negative, I'm moving slower. So I'm slowing down to the left. The position of an object thrown upward on the moon is given by this function, where x is measured in feet and t is measured in seconds. So this is thrown upward. Find expressions for the velocity and acceleration of the object without your calculator. So the velocity, which is the change in position over time. If we do the power rule, we multiply times negative 2.7, we get negative 5.4 t plus 27, and remember the derivative of 6 is 0. And the expression for acceleration is a change in velocity over time. So the derivative of the velocity function is just negative 5.4. Since the position was measured in feet, time was measured in seconds, we can put our units. We can find the time when the object is at its highest point by finding the time when the velocity would equal 0. Velocity equals to 0 means the slope is equal to 0. So we're going to use our calculator to figure out when negative 5.4x plus 27 equals 0. But we really don't have to use our calculator for that. Negative 5.4t plus 27 equals 0. So not at time 0, but when velocity is 0. Means 27 equals 5.4t. 27 divided by 5.4 is the same thing as 27 divided by 220 times 2.7. This does cancel with a factor of 10, so the answer is 5. So at t equals 5 seconds. Now, only because the decimals would be a little burdensome, we're going to go ahead and figure out what the height would be at that time. The height at that time is negative 2.7 times 5 squared plus 27 times 5 plus 6. Notice for all of my multiplication, I'm using parentheses. So our height at time 5 is our x of 5 is 73.5. And again, our position was measured in feet. Okay, so let's look at some of our practice problems. The graph shows the velocity of an object. It does not show the position. At what times does the object reverse direction? Remember, direction is determined by the sign of velocity. So from time 0, the velocity is 0. Between 1 and 3, The velocity, notice, is the y value. The y value, the y-axis, is the velocity function. So the y value is positive, and then after that, the y value is negative. So that means the particle was moving forward, has a velocity of 0. So we were initially stopped. Move forward until time 3. The velocity is 0 again at time 3 and then moves backwards. So the object reverses direction at time 3 only. If you try to look at the slope of these graphs, the slopes of these graphs are actually acceleration. That same graph shows the velocity. On the interval 0 to 7, how many times is the acceleration undefined? Well, we just said the slope of velocity is acceleration. So it's going to be undefined every time there's a sharp turn on this graph. So how many times it's undefined is 1, 2, 3, 4, 5 times. There are 5 times that the acceleration is undefined because the slope of velocity is undefined. Okay, this next one, it says the velocity is shown in the graph. The graph shows the velocity. That means the y value is the velocity, which means the slopes are acceleration. So this is not a position graph. So the first question says, what is the maximum speed of the object? So we can talk about what speeds we have. At time 0, the velocity is -2. At time A, the velocity is 0. At time 2, the velocity is 8. At time 4, the velocity is 9. At time B, the velocity is 0 again. And at time 6, the velocity is -5. That means that the speed at each of those times respectively is +2, because speed doesn't care about the direction, it only cares about the absolute value. 0, 8, 9, 0, and 5. So the maximum speed is 9 units per second. Now, when is the speed of the object the least? Remember, you're not looking at the velocity graph anymore. We're looking at this column of speed that we made, and the smallest value for speed is 0. And that occurs at times A and B. Now, the acceleration, we said, were the slopes of this graph. So the acceleration, we'll do that in red, is positive, undefined because of the sharp turn, positive, undefined, and then negative. So the acceleration is positive all the way from 0 to 2. From 2 to 4. But not from 4 to 6. So the correct answer is C. The acceleration is negative by that same turn between 4 and 6 only. So 4 to 6. Be careful not to choose 4 to B because they look kind of the same. The same graph on the interval 0 to 6, when is the acceleration undefined? We said the acceleration was undefined when the slope of velocity had a sharp turn. So at 2 and 4. And then on the interval 2 to 4, what is the acceleration of the object exactly? Well, remember, we said the acceleration is the slope. We can find the exact slope because it's just a straight line segment. So we have the points 4, 9 and 2, 8. So the slope is y2 minus y1 over x2 minus x1. So 1 over 2. Notice that we should have had a positive slope, so a positive acceleration between 2 and 4. Now, when is the object furthest to the right? That can be a little trickier. So let's look at what happens. Our object moves to the right at time 8, from time 0 to time 2. Kind of has a little hiccup there. Maybe it ran into another car. We're not sure. And then it moves to the right at a slower rate from 4 to 9. But now we have to look at all of this in terms of our slopes versus our velocities here. So we have to be very careful. The y value is velocity. So that means that for this little part here between 0 and a, we're actually moving backwards. So if our starting point were here, t equals 0, then we travel backwards to get to time a. Seems a little weird because you think about this as slope, but the y value is velocity. Now from a to 2 to 4 to b, all of this y value, the y value, is positive. Here we have a y value is negative, and here we have a y value that's negative. So from A to B, that entire time, we turn around and go to the right. But then at time B, our velocity is 0. Velocity is 0 means we've stopped. And we turn around and we have a negative velocity until time 6. So we are furthest to the right at time B. So remember, the velocity was the y value was negative, 0, positive for a longer time, 0, and then negative. That was going backwards, stopping, going forwards, stopping, and then going backwards for a little bit. So our furthest to the right time was right here. Okay, for number 3, a projectile starts at time 0 and moves along the x-axis, so this position for only positive times is given. What is the velocity of the particle at t equals 0? Well, velocity at any time is the derivative of position, which is 3t squared minus 12t plus 9. So the velocity at time 0, I'm going to substitute 0 in for all the t's, and I'm simply going to get 9. So again, we're given a particle's motion. T has to be positive. T is in seconds and distance is in meters. So notice they're looking for velocity. And so all of these are meters per second because velocity is the change in position over the change in time. But notice what they've asked us for this time. They haven't asked us for the instantaneous velocity. They have said average and during a time interval. So we have to talk about what that means. During a time interval, if I started a stopwatch, my stopwatch would start at 0 seconds. And it would hit 1 second, 2 seconds, 3 seconds. So during the first second is from 0 to 1 second. During the second second is between 1 and 2 seconds. During the third second is between 2 and 3 seconds. So the average velocity is the change in position over the change in time. So there's a difference between our instantaneous rate of change and our average rate of change. So we need the position at time 3 minus the position at time 2 over 3 minus 2. So the position at time 3 is 3 cubed, which is 27, times 4, which is 108, minus 3 squared, which is 9, times 5, which is 45. And 108 minus 45 is 63. So remember, that's x, so it's measured in meters. Our position at time 2, 2 cubed is 8. 8 times 4 is 32. 2 squared is 4. 4 times 5 is 20. 32 minus 20 leaves us with 12 meters. So the displacement is position B minus position A over our time interval. 63 minus 12 is 51. 3 minus 2 is 1. We put displacement over time. So it's 51 meters per second. My battery's about to die, so I'm going to pause this for 1 second. Okay, we're back. For the next problem, the position of a particle at any time is given. When does the velocity equal 0? So we don't know the time, and we have to not substitute 0 in, but find the velocity and set it equal to 0. So we want to find the velocity first by taking the derivative of position. Using the power rule, we get 3t squared minus 9t, because 2 times 9 halves cancels, minus 12. And then we want to know, when does the velocity equal 0? So we're going to set that velocity function equal to 0. First, I'm going to pull out my GCF, which is 3. And then I'm going to factor the quadratic. So our options are to set each term equal to 0. Well, 0 can't equal 3, so we don't really need that part. But then t would have to equal -1, and t would have to equal 4. Both of those times are positive or not. It's a little bit tricky. Position typically does not allow us to have a negative time. They didn't state it specifically this time the way they do in most of the problems, but we don't typically allow a negative time interval. And most of the problems nowadays do list time has to be positive. Okay, so we have another position function given. At what time or times is the velocity equal to 0? So time is the question mark. We're not substituting 0 in. This time we have a product. So my velocity function, which is my s prime function, has to use a product rule. So for the first part, we have t squared minus 5t plus 2. The second part, we're going to take a derivative. So we use the power rule. Okay, so plus. Now we're going to take the derivative of the first part, 2t minus 5. And then we keep the second as the regular part. So remember, we only do one derivative at a time, and we kind of do a wife swap there. Now, we need to be able to set this equal to 0. That means we have to use the GCF again. So if I'm looking at these, I have a GCF in these terms. I can factor out t minus 2 to the second power. That leaves me with t squared minus 5t plus 2 being multiplied by just 3, plus it leaves me with a 2t minus 5 being multiplied by a t minus 2, because remember we only factored out 2 of them, not all 3. So 0 equals t minus 2 squared, and I have to start simplifying so that I can see if I have any other zeros. So I'm distributing the 3.